Markiplier's movie adaptation of the game Iron Lung is finally here, and with how intriguing the premise and the lore of the game is, it's not surprising that he chose this game to make a movie out of. However, this video will be more specific to the game mechanics. For those who may not be familiar with the original game, here's a quick summary of how the game mechanics work. You have to navigate a blood ocean in a submarine called the Iron Lung, but the twist here is that you can't actually see anything. Instead, you're shown your position in XY coordinates and the current angle you're at, and you have to find on the map where you actually are, and then you press the buttons to make sure the numbers line up to where you don't hit anything. There's another button in the back of the submarine where you can take a picture of what's currently in front of you, so you do have vision to some extent. The goal then is to go to several marked positions and angles throughout the map and take pictures at said locations and angles. This is where my project comes in. My goal was to build the main console with Raspberry Pi and simulate the main gameplay loop, and I called it Iron Lung. Get it? This was a really fun project to work on while I'm still transitioning from being just a programmer to working with electronics. There are a few obvious differences between the original game and my version, but I do really like how my interpretation turned out. Hello, my name is Nathan, and this is Guh-Roo's Gadgets. To start off, we need some displays to actually connect to the Raspberry Pi, so I chose a 240 by 240 display for the main display, and then a couple of 128 by 64 displays to show all of the text information. The main display will swap between showing you the current angle of your ship and the overall map, and the other displays will show your XY coordinates, your angle, and the closest goal point. I'm using Python for this project because there's a lot of really well documented libraries to work with Raspberry Pis, and it's a good excuse to finally use Python for a full project. Step 1 was getting a ship to rotate on the main display, and I started this with Adafruit's display IO library to render a single triangle. More specifically, I used the polygon function in vector IO. So in computer graphics, the order of the vertices in a triangle does matter when you're actually drawing the triangles, and because display IO is a bit finicky, I had to learn the correct order, and it wasn't really just clockwise or counterclockwise, but because the positive Y is down, it kind of swaps the way I would normally interpret this. Once I did get a triangle properly drawn, I checked to make sure that I was able to move it with buttons. After that, I made a ship design with 4 points that looks closer to the one that you see in the game. The math for rotating all 4 points wasn't too complex, but I did run into issues with vertex ordering again, specifically when connecting the final point back to the first point. After some headaches with a few over-engineered functions to swap the order of the vertices, I eventually just added a 5th point where the first one is. However, this was extremely non-performant, especially with the other displays running at the same time, even if I'm only drawing when the data changes rather than on every single frame. I did briefly consider swapping from the Raspberry Pi 02W to a Raspberry Pi 5, but that didn't really feel right to me, because the solution to non-optimal code isn't to just get better hardware, it's to optimize your code. I instead swapped to OpenCV, which runs off of C instead of Python, and although this was more complicated to set up than Display IO, it was way more efficient, and after doing some cleanup, I got it even more optimized. The text displays were much simpler to implement. First of all, I did need to use an I2C multiplexer to actually connect all of them to the Raspberry Pi at the same time, but thankfully the main display is SPI, so it's already separate. Of the 64 rows in these displays, the top 16 are yellow and the rest are blue, and I chose these ones because I thought it looked a bit cooler than to just have a display that's either all white or all blue. The movement was actually pretty easy since I already had the angle, which meant all I had to do was use sine and cosine to get the x and y components of the angle, and then just move in that direction with 2 more buttons. I did some more tweaking with the turning and the movement so that it felt right and also included momentum. I didn't want to just be confined to a breadboard, so that did mean I needed to get to soldering. I've only done a little bit of soldering before this project, so I got a couple of starter project kits on Amazon. This way I could avoid the beginner mistakes on the real project, but I say that like I didn't accidentally scorch one of the displays. The one with the grid of LED lights was pretty simple, but it does make some pretty cool patterns as you adjust the dials. The car simulator one uses a microcontroller, and it's actually pretty in-depth for a simple project. These were not only helpful to get me more comfortable with soldering, but they also helped me get a better grasp of electronics than I have just from reading books. Now, you probably already noticed the soldering prototype boards in some of the clips I've been showing. I started with 2 smaller ones because that's just what I had lying around, but I quickly decided that no, I need to have one larger one. I used solid core wire for this because I originally wanted to make it look really nice and organized, but that quickly went out the window when I realized just how long that would take. It does look a bit spaghetti-ish, but I wanted to do this one by myself instead of going straight to custom PCBs. This worked out because I had to rewire a couple of times and I ended up adding a 4th text display later on. I also had a couple of feet that came with the Raspberry Pi that I was using to hold up the board, but those ended up being too short, so I 3D printed some more that I found on MakerWorld. Since I also have a full bag of MX key switches that I'm going to use for a future macro keyboard project, I decided to use these instead of the click buttons just because they felt nicer. This also meant that I could more easily have buttons that look closer to the ones that are in the game. And so with my nearly non-existent Blender experience, I threw together a model for the arrow keys. And before anyone says anything, yes, I'm well aware that using a proper CAD software instead of Blender would be much faster, but I'm using Blender because I've wanted to learn it for forever now, and I will be using it for other use cases besides 3D printing, including 3D models for video games. The stem sockets ended up being too small, but that worked out because I ended up wanting to do a version that actually had walls anyway. The ones I used for the 2 movement buttons didn't fit right, I think because I printed out 4 identical ones instead of having 2 of the stems rotated. Not sure on that, so don't quote me. So I made a rotated version while also modeling a simple circular shape for 2 more buttons. I did accidentally use the wrong filament on this print, but the circular ones were too small anyway because I needed to make sure they didn't hit each other because of how close they were on the prototype board, so I had to reprint anyway. After just going with the simpler square design, I made sure to actually select the correct filament and then print it again. The next 2 buttons are really essential to actually being able to complete the game. The button on the left pulls up the map, which I made by using the Python maze-lib library to generate a random maze. Specifically, I used the Dungeon Rooms maze generation algorithm to mimic some of the more open spaces you see in the actual game. After doing some tinkering with it, this provides a decently randomized maze that has the same general shape between each playthrough. I couldn't just use the straight-up text as a maze though, so I transferred the grid data of the maze over to OpenCV to generate the shape properly. Then of course I made it red because blood. The proper map in Iron Lung does display the coordinates along the XY axes, but this display is really too small to realistically do that. So instead I added a green dot to signify where the player currently is in the map. I also added in lines to see the grid itself, which helps you more easily determine where you are, with each square representing an area of 10 by 10 units. This means that every time one of the coordinates changes in the tens digit, you move over by a space in the map. So if you want to go to the next grid location in any direction, just go about 10 units in that direction. This does kind of go against the original point to need to read the map closely to know where you are, but the map does disappear whenever you try moving again. On this point, I can't really simulate taking pictures to show where you are with this setup anyway, since that would require actually rendering 3D models, which I'm going to avoid for at least this version of the game. To be fair, the horror element of Iron Lung is kind of lost with this form factor anyway. At least for now. Great, so now we can move around the map, but the ship has no concern for walls. Fixing this was as simple as adding a check whenever the ship moves to see if the current grid spot in the map is a wall. If it is, it goes to game over and the map is pulled up one more time for a final reference. In the actual game, dots show up around the ship to warn you of an obstacle, with the blinking speed indicating how close it is. I chose to instead use solid lines if you're next to a wall, and I could have used the blinking dots, but with the performance already being in the state it was, I didn't want to have too many extra draw calls, and this way I would only have to update the image of the ship when it rotates, or when moving to another grid position that has a different wall border set up. I like this version too, because it gives the impression that you're actually zooming into the maze to see a closer view of the ship. While testing at this stage, I realized that since it's a properly made maze, there's really only one solution, which means that navigation will take forever to get anywhere, even with the rooms I included. To counteract this, I added a few more hallways that clear through the entire maze, and not only does this make it easier to navigate, but it creates a lot more smaller pocket rooms to vary things up a little bit more. The next mechanic I worked on was the various points of interest. When the maze is generated, I grab all of the spots that are hallways and store them in another list, so this way when I want a random location, I don't have to worry about it accidentally being in a wall. At first, I only had one goal point on the map at a time since I could only display the data for one point at a time, but this felt more like Snake than Iron Lung to me, so I did bring it back up to 8 points at once. I'm calling the button that's used to check if you're at a goal point the scan button, so it also scans for the closest goal point. That's how you can check on the exact location and angle of the goal point you're currently headed to, and it even makes it appear as cyan instead of blue on the map. If you're actually at any of the goal points, it'll remove it from the list and update the next closest one. It is using absolute distance rather than figuring out a path through the maze to avoid the extra calculations, but my justification for this is that it's more of a radar scan. In this form factor, a radar scan button feels like a good substitution for the actual game's camera system, at least to me. I did encounter a bug where some of the goal points were appearing in the walls for some reason, even though they should be taken from a list that is only the hallways. After some head scratching, I made the list of goal points equal to the number of hallways so I could actually look at the map and properly see what was happening. It might be hard to tell, but if you look closely, you can actually see that the map formed by the data points is mirrored along the y-axis. This happened because I may or may not have slightly overcomplicated the various coordinate conversions and forgot to do one more subtract. Finally, if you do run into a wall, you get a game over that tells you how many of the data points you collected. And if you do win by getting all 8 data points, well, there was only one proper way I could think of to reward the player with winning.
295 confirmed beautifully. Oh!
And with that done, I finally had a working game, and I love the way this plays, and it has been such a rewarding project to work on. I'm definitely planning on further developing this prototype in future videos. I've been going back and forth on the idea of the camera buttons, but I definitely want to add in some form of monster that can attack you. Maybe the only way to avoid it is by temporarily staying still. I also want to add more games, including a battleship game that is multiplayer if you have multiple of these devices, which I plan on making. On that note, now that I have the wiring sorted, I want to actually use proper custom PCBs, as well as designing better fitting keycaps. Thank you so much for watching, and don't forget to like and subscribe